So the next part of geology we want to talk about is economic geology, and this is geology concerned with earth materials that can be used for economic and or industrial purposes. We're going to talk about metal resources and non-metal resources. So first, metal resources. Metals consumed in the greatest quantity by world industry. The highest one is iron, and then aluminum, manganese, copper, chromium, and nickel. And this shows some of the uses for some of these. So aluminum, we all are familiar with aluminum cans and aluminum foil, but it's also used in transportation and electronics. Iron here is used for heavy machinery and steel production. Manganese has high strength, heat resistant steel alloys. Copper is used for building construction, electric and electronic industries. Copper wiring is something that's often used. Chromium is used to make high strength steel alloys, and nickel, chemical industry and steel alloys. So this includes, I went through these ones that are the greatest in quantity, but there's a few other ones listed here if you're interested in them. I do want to point out, we're going to talk a little bit about mining and things like that, but metal recycling is something that's actually really important for the amount of metal resources available and how much energy we have to use to get different metals. So metal recycling does not deplete the resource further, and it's less energetically costly than extracting from the naturally occurring raw material. So mining is almost always takes more energy and is more environmentally devastating than pulling out metal that we've already mined by recycling. So recycling it does take energy because usually we're melting these metals down to make them into something else. But they are almost always a better choice to use the recycled metal. All right, what are some non-metal resources? We have gemstones and precious metals. Extraction methods can be very environmentally damaging. These are worth so much that a lot of times we see gangs, terrorism, and inhumane labor conditions to try and get at these things that are worth a lot and get them out of the ground. Sand and gravel is something we probably don't think about a whole lot, but they account for the greatest volume and dollar value in terms of economic geology. So these are used for brick and concrete construction, paving, sandblasting, and glass production, but it does produce a lot of dust and particulate matter. The last group is coal, oil, and natural gas, so basically fossil fuels. These are deposits from formerly living organisms that were carbon-based. It's very high energy, but burning it produces carbon dioxide, which is a greenhouse gas, and other byproducts that can have environmental problems. So how are fossil fuels formed? So we're going to talk about coal and oil and gas. So coal took at least millions of years to form from land plants. So generally these huge ancient fern forests that existed about 300 million years ago or more, these huge forests grew covering most of the land. This vegetation dies and becomes peat. If you do gardening, sometimes you buy peat, they mine it, but it's basically vegetation that doesn't completely decompose. A lot of times it's formed in swamps or bogs or things like that where there's not a lot of oxygen, and so the plant material doesn't decompose. The peat is compressed to form lignite, and heat and pressure further compress it to form bituminous coal. Sorry, that's hard to say. And eventually it becomes anthracite. All right, so let's look at oil and gas. It took at least millions of years for oil and gas to form from ocean plants. So coal is from terrestrial plants, oil and gas are from aquatic plants, oceanic plants like phytoplankton and algae, and this takes hundreds of millions of years. Marine plants and animals die and sink to the bottom of the ocean, at the ocean floor. These plants and animal layers get covered with mud, and over time, more sediment creates pressure, compressing the dead plants and animals into oil. So you can see there's lots of material on top. It's pushing down, lots of pressure, and it creates this layer you can see here as oil. As the rocks break, and in any porous rocks, the oil will move up and create these different reservoirs that we can mine the oil from. Okay, so where can we find coal in the United States? You are probably familiar with some of these. We all probably have heard that places like West Virginia and Pennsylvania and Eastern Kentucky have a lot of coal, and that is totally true. There are a lot of coal mines in this area, but we can see that there's different kinds of coal distributed through large parts of the United States. There's coal seams around the Rockies. There's even some deposited in Louisiana, but most of the extraction is coming from this area of the country. Where do we see oil and gas? So the green is oil production and the red is gas production. And you can see right here, we have a ton of natural gas wells in northern Louisiana, which a lot of you are probably familiar with. But if you look at satellite images of the area around Ruston, especially to the northwest, you'll see that there are just tons of gas pads where they're extracting natural gas. But you can see that there are other places where there are large oil and gas reserves as well, and some of them are offshore too. And you can see there's some concentrations in Alaska. Alaska also has high oil and gas production. Okay, so this shows different pipelines to move the oil and gas around through the country to refineries. And this shows where the operable refinery locations are. This is a little bit dated. This is from 2012. But you can see that the Gulf Coast has a whole lot of oil and gas refineries. And this is where a lot of the oil in the country gets processed. Okay, next we need to talk about different types of mineral extraction. We have placer mining. This is hydraulically washing out metals deposited in streambed gravel by using water cannons to blast away the stream bed. So you can see this here. These are the water cannons, and they're basically blasting away this gravel. This has some environmental issues for sure. It tends to destroy these stream beds, and it fills the water with suspended solids. So it's causing a lot of erosion on purpose, but a lot of that sediment will end up in our waterways, which can be problematic for our water quality and also for organisms that live in those freshwater ecosystems. Okay, another method is underground mining, which is probably what you think of when you think of mining, because that's what usually shows up in like movies and stuff. So this is tunneling into mineral seams, and it can be very dangerous. So you can see here we have different tunnels going into these to pull out coal in this example. It's very dangerous. People, especially for coal, getting that coal dust in your lungs can cause lung cancer and emphysema and lots of other problems. But it's also dangerous immediately. These tunnels can collapse. There's also often natural gas down here, which can cause explosions. Sometimes water seeps into the mines, dissolving different toxic minerals, and this can lead to groundwater contamination as well. All right, another type of mining is called open pit or strip mining. 50% of U.S. coal is strip mined. Basically, it creates these big holes in the earth, and sometimes these fill up with water, and that is often contaminated. So heavy metals or other mining byproducts will be in this water, and we don't have a good way to get rid of it. Another thing that can happen is surface material will be left in long ridges, which you can see illustrated here. And these are called spoil banks. This is just extra material from the strip mines that they don't have anywhere else to put. That also does not have a lot of economic value. So they're not going to actually extract anything out of it. So it doesn't contain any topsoil. So usually there's not vegetation forming on these for a really, really long time. So it's just kind of open sediment that came out of the mine. Okay, another one is called mountaintop removal. This is common in Appalachia for extracting coal. And basically they remove ridge tops to get to a coal bed. The material from the ridge is crushed and dumped into adjacent river valleys, bearing streams. And often there can be different contaminants in that material that can degrade water quality. So there have been lawsuits about this because this can violate the Clean Water Act, which we'll spend some time on later in the class. But mountaintop removal has been very controversial. It's basically taking off the whole tops of mountains. And the footage of this is kind of shocking because we don't think of mountains as something that are being taken away. So that's a pretty big issue as well. Oop, wrong way. Okay. So coal mines, we see active surface coal mining operations on this map, which we can see are concentrated again in Pennsylvania, West Virginia, Eastern Kentucky, a little bit in Virginia and Ohio, and scattered around the rest of the United States. And this shows active underground coal mining operations, which again you can see are mostly in Pennsylvania, West Virginia, Eastern Kentucky, and a little bit in Virginia, and then there's a few scattered up throughout the rest of the United States.